Chapter 3 Gravitation. Thrust and Pressure. Have you ever wondered why a camel can run in a desert easily? Why an army tank weighing more than 1,000 tons rests upon a continuous chain? Why a truck or motor bus has much wider tires? Why cutting tools have sharp edges? In order to address these questions and understand the phenomena involved, it helps to introduce the concepts of the net force in a particular direction, that is thrust, and the force per unit area, pressure, acting on the object concerned. Let us try to understand the meanings of thrust and pressure by considering the following situations. Situation 1. You wish to fix a poster on a bulletin board as shown in figure. To do this task, you will have to press drawing pins with your thumb. You apply a force on the surface of the head of the pin. This force is directed perpendicular to the surface area of the board. This force acts on a smaller area at the tip of the pin. This perpendicular force is known as thrust. Situation 2. You stand on loose sand. Your feet go deep into the sand. Now lie down on the sand. You will find out that your body will not go that deep in the sand. In both cases, the force exerted on the sand is the weight of your body. You have learned that the weight is the force acting vertically downwards. Here the force is acting perpendicular to the surface of the sand. The force acting on an object perpendicular to the surface is called thrust. When we stand on loose sand, the force is acting perpendicular to the surface of the sand. The force acting perpendicular to the surface is called thrust. When you stand on loose sand, the force, that is the weight of your body, is acting on an area equal to area of your feet. That is, when you stand, the force is acting only on a small area. When you lie down, the same force acts on an area equal to the contact area of your whole body, which is larger than the area of your feet. In this case, the force acts on large area. Thus, the effects of forces of the same magnitude on the different areas are different. That is, when a man stands on loose sand, his feet penetrate more than when he lie down on the sand. In the above cases, the thrust is the same. That is, the force is same, but effects are different. Therefore, the effect of thrust depends on the area on which it acts. That is, thrust will be same for particular body, but effects are different, and it depends on the area on which it acts. The effect of thrust on sand is larger while standing than while lying. The thrust on unit area is called pressure. Thus, pressure equal to thrust by area. Substituting the SI unit of thrust and area in the equation, we get the SI unit of pressure as Newton per meter square or Newton meter raised to minus 2. Here, thrust is the force acting downwards. So, the SI unit of thrust is also Newton, and the SI unit of area is meter square. So, we will get the SI unit of pressure as Newton per meter square. In honor of scientist Blaise Pascal, the SI unit of pressure is called Pascal, denoted as PA. Let us consider a numerical example to understand the effects of thrust acting on different areas. Numerical application. A block of wood is kept on a tabletop. The mass of wooden block is 5 kg and its dimensions are 40 centimeter into 20 centimeter into 10 centimeter. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimensions A 20 centimeter into 10 centimeter and B 40 centimeter into 20 centimeter. Solution. The mass of the wooden block is 5 kg. The dimensions are given 40 cm into 20 cm into 10 cm. Here the weight of the wooden block applies a thrust on the tabletop, that is thrust F equal to m into g equal to 5 kg into 9.8 meter per second square equal to 49 Newton. Area of a side equal to length into breadth equal to 20 into 10 cm equal to 200 cm square equal to 0.02 meter square. We have to convert it into meter square. Divide by 100. Then we will get area equal to 0.02 meter square. Then pressure equal to thrust by area equal to 49 Newton divided by 0.02 meter square equal to 2450 Newton per meter square. When the block lies on its side of dimensions 40 cm into 20 cm, it exerts the same thrust. Area equal to length into breadth equal to 40 cm into 20 cm equal to 800 cm square. And we have to convert it into meter square, then we will get 0.08 meter square. Then substitute in the equation pressure equal to thrust by area equal to 49 Newton by 0.08 meter square equal to 612.5 Newton per meter square. The pressure exerted by the side 20 centimeter into 10 centimeter is 2450 Newton per meter square, and by the side 40 centimeter into 20 centimeter is 612.5 Newton per meter square. Thus the same force acting on a smaller area exerts a larger pressure and a smaller pressure on a larger area. This is the reason why a nail has a pointed tip, knives have sharp edges, and buildings have wide foundations. Explanation. The cutting edges of the tools like knives, scissors, and blades have been provided by the sharp edges to allow the cutting of things easily with the sharp edges. The smaller the surface area over the force is applied, hence more pressure can be applied on the surface. That is, pressure is inversely proportional to the area. When area decreases, the pressure increases. So we can cut things easily with sharp edges tools. The truck and motor bus have wider tires with respect to the property that more the area, less the pressure. As the area is more, the pressure will decrease. So there will be less need for applying more pressure to handle the vehicle. The vehicle will move smoothly. An army tank weighing more than 1,000 tons can rest on continuous chain because the chain has larger area, and hence the pressure exerted by the heavy tank on the ground decreases and prevents the tank from sinking into the ground. Camel can run on sand easily because they have wide feet which help them to balance their weight on loose sand, and wider feet gives a larger surface area also. Pressure is inversely proportional to the area. So, when the surface area increases, the pressure decreases and camel can run on sand easily. Summary. The thrust is the force acting on the body in a perpendicular direction. SI unit of thrust is Newton. Pressure is the thrust per unit area. SI unit of pressure is Pascal or Newton per meter square. Pressure depends on A. Force applied on the body, B. Area over which the force acts. That is all in this topic. Let us learn buoyancy in our next topic. Thank you.